Okay, hello everyone. Let's start the stream. I forgot to change the top banner, but let's hope we will fix it in post-processing. So I will give you a bit of an intro on what we will work on. So basically, we will look into generator functions, which is a really cool feature in both in JavaScript and in Python as well. And we will build some lazy sequences, which we'll look into what are they exactly later. And basically we'll use this to create data, create sequential data, and to process sequential data in a functional style. And of course, in a real environment, you would use a library. So these are all things that are already implemented in excellent libraries. So we'll implement these things for learning purposes, but in real life, in a real project, most likely you would use a library like Lodash or something like that. And if you find that you really like this kind of programming, then I encourage you to check out Clojure, which is a programming language which originally runs on the Java virtual machine and interacts with Java, but there is also a version called ClojureScript which transpiles to JS, to JavaScript, and Clojure uses these lazy sequences and these functions we implement pretty much everywhere. So it's very ubiquitous in the language. It's everywhere. And also, if you want to dig really deep, I encourage you to check out Haskell, which is a pure functional language, and it's lazy by default. So not just sequences, but everything is lazy there. And we will see what are the advantages of having lazy stuff. So I was saying that we'll work in JavaScript, which is true, but if you want to follow along in Python, you can. I created a bit of a cheat sheet. On the left side you can see the JavaScript version, and on the right side you can see the Python version of mostly the same code, equivalent code. So first of all, this is how you will create the generator function. Let's notice that in the JavaScript syntax we have a little asterisk after the keyword function, which tells the JavaScript environment that this function will be a generator function. And this is the only syntax as of right now, so there is no arrow syntax for creating generator functions as of now. Let's hope they will be added in the future. And basically I implemented a little repeat function here. So this is a function that repeats its inputs and optionally takes an amount parameter. If no amount is provided, then it will create an infinite stream, an infinite sequence of the value repeating, and if there's an amount, it will create a sequence of that amount of values, but still lazily. And as for the Python version, it's the same. There is no need for any special syntax for generator functions in Python. If you use yield inside a function in Python, it is automatically a generator function. Okay, let's see how do you use these. So basically you just call these functions, and the result of the function call is a generator object, which will generate these values as needed. So the values and the code which needed to calculate the values will be only evaluated when you call next. So when you call the next function, in Python you need these underscores. In JavaScript you just simply call next, and that will give you the next item. But this is not really how you usually use these. Usually what you do is you iterate over the generator, which is just use it in a for loop. So you can see it's very similar. This is how you would use it in Python, and on the left hand side is how you would use it in JavaScript. And also there's a way to do a yield in steps, or I'm not sure how to call it, which is basically just yield asterisk or yield from in Python and yield asterisk in JavaScript. And what it will do is we take an argument which holds multiple things. It can be another generator, it can be a function, or it can be a collection. So anything that would produce multiple values. Basically you can produce those values one by one by using either yield from in Python or yield asterisk in JavaScript. So basically that's what we would use there. And also one more thing, which I left out. If you want to see the values, you want to turn it into like an array, you can see the values one by one. So this is called forcing the sequence. What we are forcing here is basically the evaluation of the values. So that's why we call it forcing. Now basically what you need to do in Python, you can do a call to list constructor, and you can just pass the generator. And in JavaScript you can call array dot from and also pass the generator as a parameter. So basically this is what we will do, and we will use these tools to achieve what we want. And if you want to follow along in Python, that's perfectly fine. I hope you will be able to translate the code. And if you've got any questions, then just let me know in the chat, and I will try to watch the chat and answer the questions. Okay, let's see. I already created a file, and I already started a node instance. So you can see on the left side we have a JavaScript file, and the right pane or window we've got the node process which we will work with. And as you can tell, I already tried it, so you can do basic evaluation like 2 times 4 is 8. And also what you can do, you can call functions, it runs. And I also set it up that when I'm writing my code, like 4 times 5, if I highlight it, I can send it to the process and we will see the result. So most likely I will use it that way. Okay, let's delete this. Okay, and let's try to do our repeat that we already did and try to use it. I will do it a little bit differently. What I will do is I will not add the optional amount parameter, and we will handle that a bit differently later. Okay. So I'm just writing this little comments. Of course, you would do proper doc strings, but I'm not familiar with them in JavaScript yet. So this is as much my learning process as yours. And if you have any tips, then feel free to write them into the chat. Okay, and it's going to be a generator function, so I give you the asterisk there. It will have a value parameter and basically just while true. Here the value. So that's it basically. So now I have repeat, which is usable already, but I can't really do much with it because it's an infinite sequence. I can call next on it, for example. So what I can do is I can create a generator. And I can get the next values. So tmp.next. Should probably use hell. And also you see already that next is not just returning hello, it does something else as well. It's returning hello as the value, and it's returning also a boolean, which tells us whether there are more values to return or there are no more values to return. And right now, because it's an infinite sequence, it will always be false. But we cannot really collect all of them because there are infinite many ones. So the next thing I will do is I will create a take function which will take a given amount and stop there. So let's do that. Oh, you know what? First of all, let's do a commit. And now let's do take. And of course, this function will also be a generator function because we don't want to evaluate anything, we just want to stop the yielding, basically. I will elect to take the amount as the first parameter and then take the sequence. There's no particular reason for that. Why I'm doing it is because later I might want to query this function, which means that I will separate the parameters and I will translate it to a function which takes one parameter and returns another function which also takes one parameter. That can be useful sometimes, but maybe we will leave it that for a later episode. But right now let's just go with this seemingly arbitrary order of parameters. So amount is first and the sequence is second. And what will I do? I will just introduce a counter, start from 0, and let's do a while. You know what? This is basically a for loop. Yeah. So let's do a for loop. And what we want to do is we want to yield from the sequence. So we cannot just do this. Because it will yield the whole sequence. We might want to be able to do this, but that also would try to yield the whole sequence and then again try to yield the whole sequence again. So this approach won't work. So what we need is, and we will use this trick all the time, we will use a for loop to go to the sequence and we will cancel that for loop. So let's reintroduce our counter and do a for loop of the sequence. And what do we want to do? If count equals amount, and just break. You just break the for loop there, and apart from that, we want to yield the value. And let's try this. Let's say array from take 5 of repeat of foo. Yeah, and it's not terminating. Let's see why. Repeat should be right. So that's not a problem. That should not be a problem. And we are not incrementing count, of course. Yep, let's try it now. And now we have 5 foo values. Great, so now it's working. And that's why I didn't use the amount, the optional amount parameter inside the repeat function, because we can just separate that logic. So this is more close to the single responsibility principle. This is how I would separate those concerns. Okay, take seems to be fine. So let's do another commit. And right now we can repeat the same value, but we can take an amount of it, but that's not really interesting. And I think the next step here is not just taking a constant value, but taking the result of a constant logic. For that I will do repeatedly. And what repeatedly will do is it will take callback. result. And of course this will be a generator function repeatedly. Now let's see. We need to take some kind of logic, and it will be very similar to repeat. We will do a while true, but instead of yield logic, we will call logic and evaluate it. And basically that's it. And what we can do is like take 5. And of course we can use an arrow function here. It takes no parameters. And let's just do math random. Repeatedly. And of course I cannot write, but you can see that I got 5 random values, and interestingly the 3 middle ones are really close together. It's because most likely math random doesn't reuse the seed but takes a new seed every time, and the evaluation was very close in time, so that's why it's a not so good of a random. It's a bad distribution, but you can tell that it's working. So let's do a commit. Okay, and from here on out we would like to do this kind of build our sequences, so not just repeat something, but given a logic, just build one element and all the other elements based on that. Like what we could do is we could do iterate, and what it will do is so basically this is the next step from repeatedly. It will call a function, but this function will do something with a parameter. So it takes a parameter or an argument, and the argument that it's passed to the function is an initial value, and from there on the last result. So let's see this function iterate, and it will take an init value, initial value, and then some, let's call it logic, or just transform, maybe that's more telling. And what I want to do is I want to calculate the value, and I want to yield it and then change the value to the new value. So basically I will create an inner variable called value just to be consistent, and it will start out as an initial, and from here on out let's do while. So this will be an infinite lazy sequence as well, and I will yield the value, and I will change the value to be the transform value. Let's try this. Array from take, let's do 5 again. It worked out pretty well so far. Now let's start with 1, and let's have an arrow function which returns n plus 1. And we have 1, 2, 3, 4, 5. So this way we can generate, I'll just leave it here. And another example would be like, let's do square numbers. And no, let's do the powers of 2. So 2 times 2. And let's start with 1 because that's the 0th. Sorry. Yeah. 1, 2, 4, 8, 16, 32, etc. So it works out pretty well. I will leave this here as well. And now let's do all the square numbers. Actually, let's do a commit. And to do all the square numbers, actually there's a trick. I'll just show it because I think it's a really interesting trick. Or is it for numbers? No, okay. I'm not sure it will be right. I maybe got confused, so I won't do it, but we'll try it later. What I would say to do is let's do the squares, and for that we will need map. You might be familiar with map, especially so that array, or more like the array prototype, does have a map method. So we are already familiar with that, but that works with arrays that are finite. And we will create an instance of map which will work with infinite sequences. So let's just do that. Element of a sequence. Function asterisk map, and let's call it transform, and let's take a sequence. And also, to be consistent, I'm taking sequence as the last argument here as well. Okay, and again we will use our trick of using a for loop. Yeah, basically we will yield here the transformed value. And basically that's it. So this is map in its purest form, and actually in Python I think this is how it's implemented, or really close to this. Now we can do, let's take 10 this time, let's be bold. And what I will do is I will map, I need a transform now. My transform will be n times n, and I need a sequence which will be iterate starting with 1, and another transform which is our n plus 1. Let's see. Map is not defined. Oh, I forgot to define map. And now it should be, yeah, and you can tell this is the first 10 square numbers, 1, 4, 9, 16, etc. So you can see as we go further and further we can implement more exotic and more exotic sequences. Okay. Now, as you can tell, this is getting really hard to read, but of course you can take out things. So I can call this the positives and create positives here, and I can create the squares. And that way it is easier to read, so you can refactor this and it gets easier to read. So this is how you would do the map function, and this is how you would create an infinite sequence of the squares. Okay, let's do the companion of map. A lot of times when you see map, there's also filter. So let's do filter, or rather let's do our little commit here. Yep, stage everything, map. Okay, filters, values, matching, basically yields, only values, matching a predicate. I think this is more easier to understand, so we will get the ones that match the predicate, and we will not filter out the ones that match the predicate, we will filter out the ones that do not match the predicate. So again, function asterisk filter, and what we will do is take a predicate, take a sequence, and basically do our trick with 4. And add an if predicate value, then and only then yield the value. Let's see. Is there an odd? No, it's not defined. Then let's define it just here. Oh, const odd equals given a number, if number modulo 2 equals 1, then it is an odd number. Now we have an odd. And let's do array from, and let's do take 10 filter odd, and let's use our earlier positives. Let's see, it's empty. Okay, this seems to work. Oh, yeah, I cannot just do positives here. Okay, there is something that you should watch out for. These are not referentially transparent, so you cannot just substitute the definition for the value. In JavaScript, things are mutable, so these will change. So I need to do this. Maybe in a later episode we will think about how to make them referentially transparent. Basically, you just need to wrap it into a parameterless function, and that will help, but you have to be consistent about it. And now it works. All of the odd numbers, or at least the first 10 ones. Yeah. Now let's do a commit. So this is the way you would do map and filter and stuff like that. And of course we are still returning sequences. The next one, which would be really useful, is if I could just alternate. So if I could just do a sequence of like true, false, true, false, etc. Stuff like that. And it's pretty similar to repeat, but now we're repeating multiple things. And basically what I will do is I will have it repeat the array true, false, true, false, true, false, which I can already do with repeat, and then I want to concatenate all the elements. So the only thing I need for that is concatenate. So let's do that. And of course, again, I need a function, and in that function I would just take a sequence and I would use my good old trick, just do a for loop for const value or call of sequence, and this time I will use the yield asterisk call Let's see. What I want to see is the one on the upper line. So take 4 of concatenate of repeat true false. Yeah, there it is, true false true false. Let's do a commit. And basically these are the things that you can use to build a really diverse kind of data, basically. So you can use these tools, these basic tools, to build all kinds of data. It's very useful. You can combine them. So sorry. So I think this is a part where these things are already useful, and let's see what else you can do with it. So let's see how we can combine these things. Let's say I have a sequence of 1, 2, 3, 4 times a sequence of A, B, C. Yeah, how would I create like a sequence of 1A, 1B, etc. Something like that. And I would say that this is really similar, or you might say it's really similar what you can do with list comprehensions, and I would agree. So let's try to find out how we do this. And what we need is to do something with all of the values and combine them from values from another sequence. And let's try to do this. I'm just thinking how to do the syntax, but I would say that let's try to write the syntax that we would want here, and that is something like we have sequence 1, and something like, let's call it done. Let's call it V1, and we want to have the sequence 2, value 2, and yield V1, V2. So this is most likely what I would want. And of course I'm not going to extend the prototype here. Basically that's never a good idea, and most documentations, if you read them, advise against it. It's okay if you are doing a polyfill, so like you're adding something that is already present on newer versions, then it's fine. But extending an existing prototype can be really confusing, so it's not really recommended. What you can do is we could wrap these sequences into something else and we could extend that, and maybe we will do that sometime. But as of now, let's just use this and flip everything. And take sequence 1 here and take sequence 2 here. And yield there, and of course you cannot yield outside. So I think we should just create a method for this sort of thing that is yielding one thing, and that should be called singleton. See. Oh. Yeah, let's do something like this. We can do this as of now. So first of all, let's do singleton sec, which is just sequence yielding once. Function asterisk singleton seek, and it takes a single value and returns, or more likely yields that value, and that's it. And let's see then. This is really similar to map. And basically we want to yield something and then flatten that result. So let's see. Of course it's going to be a function then. And let's see, it should take a sequence and transform, which produces a new sequence. And basically you shall return, and this is our first method, I think, where we are writing return. Concatenate map transform sequence. Let's see. Yeah, basically let's do that. Then 1, 2, 3 each, and just sing it as each. This should be the simplest form. Now we have a generator. Let's put an array from yeah, we have an empty sequence. Let's try to analyze what is happening. Oh, the map is not taking anything here. Map sequence. Map transform sequence concatenate. Yeah, this should be the right one. Yeah, still. Let's try just singleton sequence. Okay, that works. Okay, then takes a sequence and the sequence should transform those. Let's build it up step by step. Array from map. Just do the identity function and 1, 2, 3. Okay, this works. And even singleton sequence should work. Now let's concatenate. Very interesting. So this, yep, because this function is not a generator function. And now it should be. Yep, there it is. A, B, C, V2. Now where should I partition this? And we should need V1, V2, and there it is. And I left out the singleton sequence, of course. There it is. And basically these are list comprehensions with syntactic sugar. So this is what happens in the background when you are creating list comprehensions. This is the logic for it. And of course we are using finite sequences to start out here, but we could use infinite sequences here and take the first few. So that would work. Basically that's it. And maybe in later installments we will try to figure out some way to make this more readable. You can already tell that with the 10 name I'm aiming for something like promises. So we could make it, if like I said, if we would wrap it in our own type, we could change the dance. Now maybe we will do that. And even further on later installments we will try to do something like async and await. So we'll recreate something like that syntax, but it will work with these sequences. It's going to be a very interesting hack. I think there are like 1 or 2 episodes at least until we get there, but it's a very neat and interesting trick, and we will use generator functions for that trick as well to basically build our own async await like syntax, but not just for async stuff, but for anything that is, you know, wrapped in something. So like async computations are wrapped inside, or async values are wrapped inside these promises, and sequence values are wrapped into these sequences and stuff like that. We'll get more and more general and see some patterns. I think I will do a commit here and stop here. And do more frequent episodes and get much more further and get into these, how we can do our own kind of computations and how we can wrap them into like async await like syntax and just build a functional framework from there on. Thank you for watching, and if you have any questions let me know in the comments, and see you next time.